All right. You are now looking, this is part 2. This is concept development for module 6, lesson 18. So what you're going to do is you're going to use a pencil or a pen, and you are going, and maybe your tools, your set square here, and you're going to connect the dots in alphabetical order. So you're going to connect A to B, C to D, B to C, then C to D, and then D to E. All right, look at those points. Now, before we go any further, let's write out their coordinate pairs. So A would be 1, 6. B would be 1, 8. C is 3, 8. D is 3, 10. And E is 5, 10. What do you notice about their X and Y coordinates? Well, it looks like they share, they share, they share, they share. Now I wonder how this pattern would continue. So it goes 6, 8, 8, 10, 10. Where do you think it might go next? So think about that for a second. So it looks to me that it's a pattern that's starting to increase. So what I want you to do next is I want you to use your ruler or set square or straight edge to construct a line of symmetry, and I want you to label it L. Okay, now here's the rule. You have to create a line of symmetry for the rule X is always 5. X is always 5. So X is always 5. So what does that mean? Oh, if X is always 5, so at 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 7, 5, 8, 5, 9, 5, 10, right? So if X is always 5, I know my line of symmetry is going to run right through here, and I told you to label that L. Now, in the last lesson, we were drawing geometric figures, and we used a set square or a ruler or a straight edge to see a line perpendicular to the line of symmetry. We measured to make sure the corresponding points were the same distance from the line of symmetry. So we were counting, right? So I want you to imagine a line that is perpendicular to L. Perpendicular to L that goes through point A. So what would that look like? It has to be perpendicular and it has to go through point A. All right, here is our perpendicular line. So, question, what is the distance from point A to the line of symmetry along the perpendicular line? What is the distance? Well, did you count 1, 2, 3, 4? It's 4 units. Excellent. All right. Now imagine that we continued, that the perpendicular line continues past L, and I want you to then find a coordinate for another letter that would be exactly a letter F, and I want you to find it over here. I want you to find a point on the other side that is symmetric to point A, and I want you to label it point F. Go ahead and try that. So, well, 1, 2, 3, 4. So over here, because it has to be symmetrical to about the line of symmetry, we know it's 1, 2, 3, 4. And we're going to label this F. So now what I want you to do is I want you to complete this. I want you to recreate this figure on this side. So I want you to go ahead and try that. And then connect the points. Try that and come on back. All right, is this the figure that you ended up with? Well, how did you solve that? Did you just count the units and you knew how, if it was 2 units on this side, you knew to go over 2 units on this side? All right, so what I want you to do next is I want you to now write the coordinates for I, and I want you to label these I, H, G, F. I want you to label those, and I want you to go ahead and put in their coordinate pairs. Come back and check your work. All right. Now I want you to compare the coordinates of the symmetric points on tables A and table B. What do you notice? What can you say about it? Well, hopefully what you're thinking in your head right now is the y coordinates are always the same. The x coordinate changes, but the y coordinates don't. So why is this true? Well, we are moving across a vertical line to draw the points. Moving left, when we move left and right, changes the x, but not the y. Because when you're moving right and left, you're changing the x coordinate, but you're not changing the y coordinate, right? So we are moving parallel to the x-axis to find the symmetric points, so that the points are on a line that is perpendicular to y. So the points must have the same y coordinate. All right, let's create a new line of symmetry. Use your ruler or straight edge, and we're going to now, well, we already did connect this line. Let's label this M, line M. So the distance is 0 from line A to line M. They lie right on the same coordinate. So what I want you to do is label the point symmetric to B. Oh, it's G, right? So now we're going to find, so we just made a figure that is symmetric about the line L. Now we're going to make a figure that is symmetric about the line M. So what I want you to do now is I want you to plot the points to make the same figure but below. Then I want you to record for this quadrant, I want you to record here. And for this quadrant, I want you to record here. Go ahead and try that and come on back and check your work. All right, is this what you ended up with? Oh, I forgot to connect these. Were you able to successfully create a symmetrical figure on a coordinate plane? Were you able to plot the points? Were you able to figure out what those points were? What do you notice about table C and table D? Well, it's 1, 4, 3, 4. 3252, 9474, 72. All right. So, what do you notice about the points that when they are symmetric about a horizontal line? Well, hopefully you're thinking it's the opposite of a vertical line of symmetry. So it's opposite, because before we were going this way, now we're going this way, up and down. The x coordinates don't change, but the y coordinates do. The y coordinates are the same amount greater than or less than 6. Remember, this was going up. This started at 6 and started going up, right? These are all less than 6. So, when a figure is drawn about a horizontal line of symmetry, the x coordinates remain constant while the y coordinates change. All right, going back to our objective for today. Our objective is to draw symmetric figures on a coordinate plane. Is that what we just did? Yes, it is. All right, now for table E, down here, you are going to create some asymmetrical figures across a diagonal line of symmetry now. So what you're going to do is now you're going to use your ruler or straight edge. And what I want you to do is first, I want you to plot the points in table E, and then I want you to connect them in alphabetical order. All right, try that and come on back. All right, is that what you ended up with? All right, so what you're going to do next is now you're going to use your ruler or straight edge to connect the points in alphabetical order from H to A. Oh, and then when we're done, okay, so you're going to connect them, and then at the end, you're going to connect H to A. All right, go ahead and go and come back and check your. All right, is this what you ended up with after you connected all of your points? Question, is this figure symmetrical? Could you fold it and have it line up exactly on itself? Yes, it's kind of like a leaf. And if I turn the plane at an angle, the left and right are symmetrical, right? If I folded it, the left and the right are symmetrical. So if I drew the line from A to E, a line from A to E, then that would make two symmetrical halves. So why don't we do that? All right. This figure is symmetrical about a diagonal line. It begins at the origin and goes through points 1, 1, 2, 2, 3.5, 3.5, and so on. Let's label this line N. So make sure to use a pencil or a pen to lightly connect the points that are symmetrical to one another about N. So predict the angle at which these segments intersect. How do these angles intersect? Well, they should intersect at 90-degree angles. If the points are symmetric, the lines and segments should intersect at right angles. All right. Now you could go back and actually check it with your protractor if you'd like. For these points to be symmetric, what else must be true? They have to be the same distance from the line of symmetry, number one. The distance along the perpendicular segment must be the same from the line of symmetry to the points that correspond on either side of the line of symmetry. So, if we measure the distance of these points to the line of symmetry to confirm that they are truly symmetric. So if we started going, okay, how many boxes is this? It's a distance of 2, right? This would be a distance of 2. So if you actually started counting it, measuring the distances, you could figure out for sure, yep, this is symmetrical. All right. This ends our concept development for Module 6, Lesson 18. Now it's time for you to take on the problem set. So let's take a look really quick at that problem set. All right, so here is your problem set. Problem number 1. You are going to use the plane to the right to complete the following tasks. Just follow along. You're going to do extremely well at this. And problem 3, you're going to use the plane below to complete the following tasks. Here is your exit ticket, and here is your homework. I think this is going to go well. You can check back to check your work after you've spent time going through and trying every single problem, writing out your answer. Then come back and check the Module 6, Lesson 18 problem set debrief.